Greetings again. So now we will introduce you to functions. We have seen those before, but these functions were not user-defined functions. That means you did not create them yourself, other than main. So examples of functions you didn't create is system. System is a function, and we're calling it within main with an argument pause. So when this runs, let me just compile this for a second to show you. We've seen what it does. It basically brings up this message, press any key to continue, which is really from DOS, from Disk Operating System which comes with Windows, okay? Since I'm on a Windows-based machine here. So there is a command pause that you can type at the prompt while you're in DOS, and it will bring up this message right here. Now, what if I wanted my own message, right? So we've seen another function called printf, right? So printf, hello there. Now, again, this is not a user-defined function. That means this is a function we could use by supplying it with an argument that it will handle and print to the screen. So let's go ahead and compile and run. There you go. And what you get is hello there. So it will execute hello there before it executes system, right? So we have these function calls within main. And main itself is a function. Main is called the controlling function in C. So what it means, it's your entry point when your program is running and your exit point when your program finally ends. So you enter your program through main, you will execute the first line within main, and when your program ends, it will execute the last line within main, okay, and sequentially in this manner. So just to show you what you can do with function calls, you can repeat calling these functions again. So I could maybe do it right here, watch this. And do a system pause before I do a hello there, and then a system pause again. So you can call them at will, and that's the advantage of having functions, is that you can call them. So compile and run. Notice I get press any key to continue, so it's executing this first system pause. So I'm hitting it, and then hello there gets executed, and then system pause again. Okay? So can I do hello there twice? Let me copy this and just paste it right below it and see what happens, right? So again, these functions will execute as many times as you call them. Okay, so the first one is system pause, which brings up press any key to continue, and notice hello there is printed twice as designed, and then press any key to continue for system pause again. Great. Now, none of these functions were user-defined. Now, why would we want a user-defined function? Well, let's suppose you wanted your own function. That's what it means by user-defined. You define it. You tell it what to do. Okay, well, let's have it one where it does a greeting. So let me clean up the code here. Let me just remove this. And hello there. And we're going to write this from main. So we know this is coming in printed out in main. So let's go ahead and run it. Compile and run. Okay, so that's hello there from main, right? So within main. Now, what if we wanted to create our own function? So let me show you where to do this. Do it before main so the compiler knows that it exists, right? So how are you going to do it? Well, for now, you will, trust me on this, you will write the word void, which means really the function returns nothing. Unlike main, it returns an integer. So if I have a void, I will not have a return statement in that defined function or user-defined function. Okay, let's call it greetings. And let's do this where it takes no arguments. And open a curly brace. Notice this. So a function, you put these parentheses, that tells me it's a function. I am defining this function. I'm not running it. So let's see what happens. What can we do in it? Well, let's do a printf. This is a hello from the function greetings. And try your functions to be lowercase as much as possible, at least the beginning. And let me put a /n, semicolon, and then I'll close the curly brace. So curly brace delineates the block that belongs to this function. Now, let me compile and show you that this is not a problem. This will compile just fine. However, if I try to run it, you would think that your program will run sequentially by printing this is hello from, let me just type this correctly here, from the function greetings. And it will not. What did I tell you prior to this? Your entry point is in main, and your exit point will be within main. So you're going to exit, the last statement will be here. So you will only execute the statements that are here. Now, what do I see? I see 3 statements in here. Printf, hello there from main, system pause, which will bring up press any key to continue, and return 0, which will return 0 back to the operating system. Okay? And you can say, okay, well, the compiler didn't complain about writing this. Is it going to execute it? Well, let's see. So let's compile and run. And notice that it does not execute it. Why? Because it never called it. You defined it. But then you can say, what's the point? Well, the point is that you're going to call it sometime, maybe in main or in some other function, right? So let's call it. And the way you're going to call it is this way. Greetings. And then notice now this here is called a function call. So let me write the comment here. This is called a function call. Just like printf is also a function call. This here is called a function definition. Okay? So the function definition defines what the function is supposed to be doing. The function call is the actual action of calling it and executing it. Well, let's see now, by compiling and running, if indeed greetings will run. So compile and run, and there you have it. Notice that the first function is the printf, hello there from main, and this is a hello from the function greetings. Okay? And notice because it's your second line. And then your third line is system pause. So it's waiting for me to press any key on the keyboard. Then it will return 0 and exit the program. So the point of this is that if you define a function and you're going to use it, then call it. Okay? So 2 components here. Now, you might say, okay, so when you defined it and you didn't call it, it will never execute it, but it will compile it. That's not a problem. What if you define this function after main? So that means let me cut this here. And you do it after main. Now let me show you here. This could be a problem. And let me compile it for a second here, show you. And there you have it. And it will tell you that it does not know who greetings is. Okay? So if you were to define a function, so you'll have to formally define it before main. So that way at compile, while this is being compiled, your source code, it will be understood where it came from. Just like when you included stdio.h, what you've done is you linked a library file that has the definition for printf and system. So before you even compile what's in main, it has to know what is it you're trying to do prior to that with greetings. Now there is a way around it. There are programmers who like to define their functions after main. Okay, so the prototype will have greetings, okay, and as a function. Let's go ahead and compile this now. Okay, so that's your function prototype. And now your definition being done after main is accepted. Right? So make sure all the names of these functions match. So greetings, and then the way you call it is the same name. Now you call it right here. The execution is done right here. This part here is the definition, And this part here is just telling the compiler to expect a definition after main for this function.